So we have some terms here: limiting reactant and excess reactant. The limiting reactant is used up completely, so that tells you the maximum amount of product you can make. For instance, in the s'mores activity, if you only had 4 teddygrams, then you could only make 2 s'mores, and it didn't matter if you had 7 marshmallows, because you couldn't make 7 s'mores if you only had enough teddygrams to make 2 s'mores. That tells you that the teddygrams were the limiting reactant. Excess reactant, meanwhile, the word excess means extra. It's the one that's not used up. Excuse me. There's always some of it left over. And we know that because it's in excess. It's extra. So this is like the marshmallows and the chocolate chips. You had more of those than you had of the teddygrams, to the point that you had leftover after you built all your s'mores. They were excess, leftover, extra. If a problem is a limiting reactant problem, check if you're given a number of moles for each reactant. That's how you'll know. Now, if you're given 2 givens and one of them's a product, you're not looking at a limiting reactant problem, you're looking at a yield problem. But if you're given 2 givens, they're both moles and they're both reactants, then that's going to be a limiting problem. Remember, when I say they're both reactants, I'm talking about that stuff on the left side of the arrow in your balanced reaction. So to solve a limiting problem, you start with the moles they gave you the first reactant and find moles of the desired product. So that's going to be your first given over 1 times a second fraction. You start over with the moles they gave you the second reactant and find moles of the desired product again. So that's 2 different fractions, where this time you're starting with the second given over 1 times some other fraction. Once you do that, you're going to have 2 answers. And you look at your 2 answers, which should both be moles of product, find which one's a larger number of moles, and cross it out. You X out the one that tells you the excess. The one that you X out tells you the excess. And then the moles of product that was smaller is your actual amount of product formed. You box this as part of your answer. The limiting reactant is the reactant, the given, that you started with to get the actual amount of product formed. It gets used up first in the reaction. The excess reactant is the one that you started with, the given, that gets you the number of moles of product that you crossed out. The excess reactant will have some leftover unreacted when the limiting runs out. So the excess has some left over, the limiting gets used up. You'll know which one's limiting because that reactant makes less of the product. You know which reactant is excess because that reactant could make more product, but you don't have enough limiting present to actually make that much product. Let's look at the next page. The first problem on this page does give us 2 givens. 4.7 moles of carbon is a given. 4.7 moles of oxygen is a given. Both of these are reactants. Carbon and oxygen are both on the left side of the arrow. They are both reactants. That tells me if I have 2 givens and they're both reactants, this is a limiting problem. If one of them was a product, it would not be a limiting problem, it would be a yield problem. Now for each reactant we have to calculate moles of product formed, so that's our unknown. And if our given is moles and our unknown is moles, then we're going to need 2 fractions where our given over 1 is on top of the first fraction. But we're actually going to have to do this twice. Once with the given of 4.7 moles of carbon, and once with the given of 4.7 moles of oxygen. Now be careful, oxygen in the given just says the word, but in this reaction it doesn't say just O, it says O2. That's because oxygen is one of your Brinkelhoff elements, so it's got to have a 2 next to it if it's not in a compound. From here, if we're thinking about the unknown going on top of our last fraction, our unknown is moles of product, so I know moles is going to go on top of my last fraction, and I actually know that's going to be true for both of these. But What does moles of product mean? What is the product? Well, the product's the thing on the right side of the reaction. There's only one thing over there in this problem, so the product must be CO. So they are actually asking for moles of CO in this problem. So that's going to be my unknown on top of my last fraction. Then if I also do what goes up must come down, I know that moles of carbon are going to move to the diagonal for my first set of fractions, and moles of oxygen are going to move to the diagonal for my second set of fractions. From here, we have to think about where does the mole bridge go. And honestly, in this problem, when there's only two fractions, the mole bridge has to go on that second one. Remember, it points from the bottom to the top in your fractions. It also points from the given to the unknown in the reaction. So when I need a number of moles of carbon, I'm going to use this 2 moles of carbon right here. When I need a number of moles of carbon monoxide, I'm going to use this 2 moles of carbon monoxide right here. .7 times 2 divided by 2 is 4.7. For my second set, when I need a number of moles of oxygen, I go up here to the reaction. There's no number in front of oxygen. That tells me there's only 1. If I follow the mole bridge, there are 2 moles of carbon monoxide, and this comes out to 9.4 moles of carbon monoxide. Now, according to my steps, when I reach this point where I have 2 answers, there's one answer that I'm supposed to keep and box, and there's one answer that I'm supposed to cross out. Well, that's because one of these is a true number, and the other one is a lie. So we need to get rid of the lie. The larger number is always a lie. The larger number is always a lie. So what's larger, 4.7 or 9.4? 9.4 is larger, it's a lie. We're going to cross it out. That means my smaller number is the one that I'm going to keep in box because it's the truth. What happened here is I recognized that 9.4 moles of carbon monoxide can never be made because I only have enough carbon to make 4.7 moles of carbon monoxide. After I hit 4.7 moles, I cannot make any more product because I don't have any more carbon. This is just like if you were thinking about s'mores again. I may have enough marshmallows to make 7 s'mores, but if I only have 4 teddygrams, I'm only going to be able to make 2 s'mores. It doesn't matter how many marshmallows extra I have, I still cannot make any more s'mores after I run out of teddygrams. So the thing that's the truth is 2 s'mores because I only have 4 teddygrams. The thing that's a lie would be like 7 s'mores from 7 marshmallows. It's the same idea as what we're looking at here. The larger number is a lie, and you've got to cross it out. Now, the one that you X out will help you figure out which one is excess. But you have to think about the fact that they're asking for a reactant in excess, and CO is not a reactant. Remember, CO is a product. We wrote that down right here. We recognized it over here. CO is a product, so CO cannot go in this blank. You have to look at what you X'd out, and then you have to go backward to the beginning of the problem. And that reactant that you started with, that is the excess reactant that goes in the blank. For the limiting reactant, the one that's the truth helps you figure out the limiting, but again, CO is not the limiting reactant. They're asking for a limiting reactant. CO is a product. CO is on the right side of the arrow. If we want a limiting reactant, we need one of these things on the left side of the arrow. So we look at our true answer that we can only make 4.7 moles of CO. We go backward to the beginning of the problem, and we find that we started with carbon. That's my limiting reactant. Then to answer, how do you know which reactant is limiting? Well, carbon is the limiting reactant. I know it's limiting because it makes less of the product. CO. You could also say that the carbon runs out first. That's also part of the definition of limiting reactant. Number 2 is similar. There are 2 givens. 6.75 moles of sodium is a given. 4.8 moles of chlorine is a given. They ask for moles of product. That's an unknown. So I'm going to have 2 sets of fractions, and it's going to be 2 fractions in each because I was given moles, my unknown is moles, I was given moles, my unknown is moles. Put your given over 1 in both sets. Once again, notice that the chlorine here is Cl2, so we need to write that 2 in our work as well. I can do what goes up must come down in both of these sets. And my moles of product, again, the product's on the right side of the arrow. There's only one thing over there. It's NaCl. That must be my product. So they want moles of NaCl in both of these places. The second fraction must be where my mole bridge goes. And I use the numbers from the mole bridge to figure out what's going into my fractions. Once I get to my 2 answers, I know that one of them's the truth and one of them's a lie. The larger number is the lie, so I'm going to cross it out. The smaller number is the truth. That's the answer I'm going to box and keep. The one that you X out helps you figure out the excess. But remember, NaCl is not the excess. The excess is a reactant, and NaCl is a product. It's on the wrong side of the arrow to be my answer for limiting reactant. So I need to go back to the beginning. I need to look at the reactant I started with. That is my excess reactant. Similarly, the one that I keep tells me the limiting, but I need to go back to the beginning and look at the reactant I started with to know what my limiting was. And that reactant that I started with sodium. How do I know that sodium is limiting? Well, sodium makes less of the NaCl. You can also say that sodium runs out first.